Welcome friends, I am Tejas Chavan from RIT Rajaram Nagar. Today we are seeing various concrete structures, but during the construction of concrete structures, proper care or quality control is not maintained. Thus, they require frequent maintenance. Me, along with Ranjit and Tejas, prepared one report on a case study as a part of ISC 1 of repair and rehabilitation of structures under the guidance of Professor Mrs. S. N. Patil ma'am. The name of case study is the structural repair and rehabilitation of 3 numbers G plus 8 multi-storied residential buildings at ONGC colony at Chandrakheda, Ahmedabad, Gujarat. The introduction is in Ahmedabad asset of ONGC, 3 number of multi-storied G plus 8 buildings that are Hira C3, the coding is given Panna B5 and Ratna B6, each having 68 quarters with half ground floor as parking, were constructed in year 1989 to 1990. These buildings were already sick due to severe reinforcement corrosion, as evident from so many spalls, delaminations on column corners located at different heights, beams, soffits, slab soffits, leached plaster on parapets, corroded and leaking drainage pipes, water supply lines, and stagnated water on terraces due to improper gradients. These were further damaged by Bhuj earthquake on 26 January 2001 in the form of separation cracks at beam column junctions, RCC masonry wall interfaces, cracks in masonry in fields, even complete crumbling at some places, heavy debonding and dismantling of plaster at both exterior and interior surfaces, etc. Due to fast deterioration, it was decided to rehabilitate this building at the earliest. For the rehabilitation work, preliminary investigation is done. Visual inspection of the buildings indicated heavy rebar corrosion as a result of carbonation due to environmental attacks. At certain location of beams, columns, fins and slabs, concrete cover had got spoiled and some shear stirrups were totally eaten by the corrosion. Beam column junctions were badly cracked. Some masonry walls at ground floor level were totally cracked due to earthquake. A number of columns had continuous vertical cracks along the line of concrete cover thickness. The visual inspection necessitated the need for detailed evaluation for design of rehabilitation design. Here we can see in a figure that delamination of beam concrete due to rebar corrosion. In second figure, severe corrosion and spalling of beam column junction due to proper workmanship and inadequate cover at ground floor level. In third figure, we can see delamination of concrete cover due to severe corrosion of rebars of roof slab. And in last figure, we can see the continuous crack along the column, and we can also see the steel exposed to environment. After the preliminary investigation, detailed investigation of the structure is done. First, rebound hammer test. Rebound hammer test was carried out at different points to assess the strength of the structural elements. Rebound numbers were determined after exposing the concrete surface by removing plaster and removing slurry, and by taking at least 5 readings at a point and averaging them. The result showed that compressive strength in the columns and beams that is varied from 11.2 Newton per mm square to 32.6 Newton per mm square. Second test is ultrasound pulse velocity test. The USPV test was carried out on 34 columns and 6 beams, and the results obtained are: in case of column, the test on the column showed good quality of concrete. Out of 34 columns, 28 columns mean observation showed good quality of concrete. 3 showed doubtful quality and 3 columns showed fair quality of concrete. In all columns, including those of good quality category, the quality of concrete either near the junction with the beam or near the floor or both had spots of relatively lower value of USPV. In case of beams, 6 beams were tested, 3 each in B6, that is Panna building, B5 Ratna building. The beam in B6 showed good quality consistently. In block B5 Ratna building, 2 beams showed fair quality of concrete with high value of coefficient of variation, that is CV, and 1 beam with good quality. On the whole, USPV values in beam were on lower end of good quality range. From the USPV tests of beams and columns, it was concluded that quality of concrete varied significantly. Weak patches are observed either near the junction of beam or at the bottom near the floors or at both. The quality variation is reflected in probable estimated strength. The probable variation is from 10 Newton per mm square to 24 Newton per mm square. Generally, the values were found between 14 to 16 Newton per mm square in sample columns. The values of estimated possible strengths of concrete in beam varied from 13 to 23 Newton per mm square in sample beams. In B5 block, these were from 19, 22 and 23 Newton per mm square. Those in sample beams in B6 were 13, 40, 22 Newton per mm square. The buildings were constructed with cement concrete. The ratio is 1 cement as to 1.5 fine aggregate as to 3 coarse aggregate. The minimum cube strength of 20 Newton per mm square, but the NDT showed that compressive strength was found less than the minimum strength required at many locations. Some members showed compressive strength even less than 10 Newton per mm square, indicating poor quality of concrete in all the 3 buildings. Third test taken was core test. 3 numbers of core tests were also carried out on each building. The results obtained are as shown in table. The 68 mm diameter core is taken in all the 3 buildings, and the results obtained are: in Hira building there is 26.17 Newton per mm square compressive strength. In Panna it is 16.52, and in Ratna building it is 24.79 Newton per mm square.
Structure is also damaged due to earthquake on 26 January 2001. An earthquake of magnitude 7.9 on Richter scale struck Gujarat and other parts of India. The epicenter of the earthquake was Dhori village, 20 km of Burj Many buildings were destroyed and some buildings developed a crack, and other structure depicted due to inadequate design and poor quality of material and workmanship in construction. These buildings safely resisted the earthquake load, but masonry walls were badly cracked while acting as a shear wall for resisting lateral loads due to earthquake. There was lot of diagonal shear cracks observed in figure number 5. Due to earthquake vibration, there were separation of crack between masonry walls and beams at the top and also between wall and columns as shown in figure 6. Plaster of the walls simply got dismantled of its area due to shaking. The same things happen with plaster on columns and beams. Some cracks in beams columns junction where is observed as shown in figure, so that it is important to repair this structure. For this following strategy adopted. First is removal of damaged plaster concrete, removal of corrosion on steel reinforcement by mechanical and chemical action, and further application of corrosion inhibitors, application of bonds of polymers cement mix to join other concrete with new mortar, then repair of RCC column beam slab by polymer modification mortar, jacketing of some columns with concrete, then epoxy grouting in RCC column beam to repair cracks, then cracks sealing in masonry walls with polymer modified mortar, then polymer modified non-shrinkage grouting in cracks of masonry walls, then concrete grading of terrace, then replacement of damaged cast iron drain pipes and water supply in GI lines, and then sealing of drainage pipe joints with PPM, then replaster paint to exterior walls. Following repairs methodology is carried out. First is the removal of damaged concrete at the location where concrete cover had already spalled as shown in figure. Then reinforcement cleaning and anti-corrosive coating. All concrete sticking to rebars was removed by light hammering and manual chipping. Then wire brush was used to remove unwanted oxides and steel surface completely. One coat of rust removal was applied to round the steel rebars. Then application of bonding coats to substrate. All the concrete surface prior to application of bond coats was thoroughly inspected and made free from any deleterious material such as oil, dust, dirt, etc. The surface was kept wet for 24 hours in ensure that they are well saturated but free of surface water after natural drying. A bonding slurry of cement and acrylic polymer in the ratio of 1:1 by volume with required quantity of water was prepared to lump free creamy consistency. Then application of polymer modified mortar. Polymer modified mortar mix was prepared in proportional cement 50 kg, sand 150 kg, acrylic polymer 20 to 25% of cement content by weight, and water cement ratio was kept below 0.5 by weight. With this mixer, the laboratory test report of one batch of acrylic polymer yielded following strength: solid content 51.2%, compressive strength 42.30 Newton per square mm, tensile strength is 4.0.1 Newton per square mm, flexural strength 40.25 Newton per mm square, direct shear bond strength 2.77 Newton mm square. And next figure we can view of building with repair with PPM.
Next we discuss about crack repairs and masonry crack and RCC crack in details. First is a masonry crack. The plasticized expanding grout admixtures along with SBR polymer was used for sealing of masonry wall cracks. The SBR polymer with the same specification as that for acrylic polymer was added to grout admixture for enhancing its bonding with the cracked machinery inside. The laboratory test of one of the batch of SBR polymer used in the work had a following property. Total solid content is 51.1%, compressive strength is 42.80 Newton square mm, tensile strength is 4.91 Newton square mm, flexural strength is 11.86 Newton square mm, bond strength is 3.06 Newton square mm. Second crack is RCC crack. Crack in RCC member, especially beam column joints, were grafted with epoxy grout of the following compositions, specially formulated to meet the required specification from erudite, and the grout was of the following properties: viscosity at 250 C max is 2 Newton square meter, minimum gel time is 30 minutes, 14 days bond strength at 250 C is 3.5 Newton square mm, compressive yield strength at 7 days is 16 Newton square mm, tensile strength at 7 days is 45 Newton square mm, elongation at break minimum is 1%. Then conclusion of our case study is there is no substitute for good quality concrete construction practices for durability of reinforced concrete structure, the quality control of material and workmanship, water cement ratio, concrete cover, compaction and curing etc., which are prerequisites for good quality construction, are very important parameter and must be strictly observed at a site. Poor quality concrete construction done cannot be rectified at a later date. Expect repeatedly costly repairs to keep the structure functional. To achieve the quality at a site, the role of manpower is very significant. The engineer and works responsible for construction should be well experienced, quality conscious, and must be fully aware of the effect of the poor quality work. Also, sufficient technical staff should be deputed for achievement of quality construction with full support and encouragement for top management. Next is the early deterioration of a concrete structure is also due to the poor maintenance practices. The water supply and drainage system should be kept intact so that there is no leakage, seepage on the walls, and no stagnated water on roofs due to overflow of water tanks or rains, which act as enemy to the structural integrity of the buildings. Next is the repair rehabilitation of a damaged structure should be carried out urgently to avoid further deterioration with time, so that the life of the structure and equipment is not jeopardized. The design for a structural rehabilitation should be carried out after laboratory testing of the repair materials, because the claimed strength in the brochures from the manufacturers may not always be achievable. Structural rehabilitation is more challenging than new concrete construction. It requires special consideration for evaluation of damage, selection of suitable material, technical specifications, and techniques for repair and quality control of material and workmanship. Therefore, sufficient time and cost allocations should be made for durable rehabilitation work. Thank you.